In the first video, we used SPSS to learn something about a population of 250,000 individuals. We analyzed a variable called var_b, which kept track of the responses to a question in the survey about the number of times individuals in that population had refused to participate in a survey when they were asked to participate in the past year. The results of that analysis are pictured over here in this document. We found that 39.1% of the individuals in that population had indicated they had never refused to participate when asked. 48.3% said they had refused only once. 9% said they'd refused 2 to 3 times. 3.1% had refused 4 to 5 times. And 0.4% indicated they had refused 6 or more times. So this is what is true in that population of 250,000. But typically, we don't know what's true of a whole population. Typically, we use samples in surveys to try to develop estimates of what is true in that population. So we can extrapolate results of a sample to the population and get some idea of what's characteristic of the population. But we wanted to know what was really true, because what we want to do is to draw samples from this population and try to see how well samples of different sizes and types do at estimating what is true in the population. So we're going to select the sample. We're going to go to Data and go to Select Cases. And one of the things SPSS allows us to do is to look at a subset of an entire data file or to draw samples from it. And initially, what I'd like to do is just pick a convenient sample. We're going to create a sample of 1,000 individuals from our population of 250,000 and see how well that sample of 1,000 does at estimating what we know is true. And we'll just pick the first 1,000 cases in the file and see what that gives us. So we're going to select cases based on case range. We're going to tell it to start with case number 1 through case number 1,000. And we're going to tell it to continue. At this point, SPSS wants to know what to do with the cases that weren't selected. It could delete them all, but we don't really want it to do that because we're going to do several different examples here. And we don't want to have to start all over again. We want to keep those other cases in, and we'll just change the search criteria. So we're going to tell it to ignore the unselected cases, but leave them in the data file. So we're just going to say, filter out the unselected cases. Don't use them in any of the analysis we ask until we change the search criteria. So I'm going to say OK. And so now SPSS has done it. And what it also does at the same time is it marks which cases it has chosen to not include in the next set of analysis. So it's showing us the unselected cases by drawing a diagonal line through the case number of each of those cases. So everything above 1,001 is now going to be used, and everything below 1,000 is now going to be ignored for purposes of the next set of analysis. So now we have a sample of 1,000 cases selected as a convenient sample from our population of 250,000. So we're going to go to Analyze. We're going to tell it to do a frequency distribution for that same variable we looked at in the population. We'll say OK. And now it has generated the results. It says it looked at 1,000 cases, and of them, it says 96.1% had indicated that they never refused to participate in surveys when asked, and 3.9% said they had refused only once. Now, this is quite different from what we know is true. This particular sample has substantially overestimated the number that said they never refused, and it has substantially underrepresented the number that have refused 1 or more times. So this particular sample, a convenient sample of 1,000, is completely inaccurate and wouldn't be very useful if that was the way we were trying to learn something about the population. So why is it so wrong? Well, some people would say that the reason this comes up with wrong answers is it's really just too small a sample to try to estimate what's accurate or what's true of a population of 250,000 people. It should be a much larger sample. So let's go up to data and select cases. Let's make a bigger sample. And instead of a sample of 1,000, let's make it a 10 times bigger sample. So instead of 1 to 1,000, we'll add another 0 over here and make a sample of 10,000. Say continue. We'll again filter out the unselected cases and say OK. And now everything above 1,000 is included up until we get to 10,000. And from 10,001 on, those are all going to be crossed out. And so everything from here on out is crossed out. So now let's do the analysis one more time of this new, much larger sample. And we'll say OK. And so now SPS is telling us that it has examined 10,000 cases, and of them, 90.5% indicate they had never refused to participate in the survey, and 9.5% had indicated they'd refused only once. Well, we know that this is a little different than the last sample, but it's still very different from what we know is really true. So even though this is a 10 times larger sample, it's a convenient sample, and it's still very inaccurate for what we know is true in the population. So what's wrong with this sample? Well, some individuals would say it's completely unrealistic to expect a sample, even as large as 10,000, to be accurate of a population of 250,000 because it's simply such a small proportion of the total population that it can't possibly be accurate. So a sample of 1,000 from 250,000 is 0.4%. A sample of 10,000 of a population of 250,000 is 4%. So those are pretty small proportions. So maybe that's the problem. So let's go up and we'll select another sample. Let's make it 10 times larger again. So we'll add another 0. So now we're going to ask SPSS to pick a sample of 100,000 of the 250,000. So that's 40%, a much larger proportion of the entire population. So let's say continue. And again, filter out the unselected cases. And we say, OK. And now all these cases that were being ignored are included. And so we have to go way down here before we start getting the cases that are going to be ignored. And from 10,000 or 100,001 all the way to the end of the file, those would be unselected. So let's go up and do our frequency distribution one more time. And here's our new set of results. So now it says it has scanned 100,000 cases. And now it's showing us something substantially different from what we had the previous two samples. It now says that 62.3% said they had never refused to participate. Well, we know that the real answer is 39.1, so this is still pretty far off. And now it's saying that 37.3% had indicated they'd only refused once. Well, that's considerably better than it was in the other samples, but it's still quite a bit different from what we know is true. We now have one of the more rare kinds of responses. We have a few people that said they had refused 2 or 3 times, but it's still quite a bit less than what we know is true. And we don't get any of the individuals who gave even more rare responses than that. So this is still pretty wrong. Still a pretty bad estimate of what we know to be true in the population. So what's wrong with this sample? Well, we just took the first 100,000 cases in it. So maybe we're just looking in the wrong neighborhoods. It was too convenient to go to some neighborhoods rather than others. And maybe the convenient neighborhoods were just the wrong ones. They aren't representative. They're the wrong side of the tracks. They aren't like everybody else. So let's take the same size sample, but from a different part of the data set and see if that gets us a more accurate sample. So let's go to select cases again. Again, we'll pick a range. Same 100,000 cases, but let's start with 100,000. 100,001. And let's go all the way up to 200,000. So it's still a sample of 100,000 people, but now it's more in the middle of the whole data file. Now let's see how well that does. So let's click continue and say okay. And now some of these cases that were ignored are now going to be included, whereas some of these down here are going to be ignored, and some of the ones at the top are going to be ignored. So we've got 100,000 cases that are pretty much in the middle of the data set. So let's go up here and ask to do another frequency distribution for variable B on this fourth difference sample from this population. Say okay, and here's the new result. Well, this is a lot different than what we were seeing before. Now it's saying in this sample of 100,000, we have 30% that indicate they'd never refuse, 52% that said they'd refuse only once, 9.8% that refused 2 to 3 times. And now we have some of those more rare kinds of cases. We have 7.8% that they said they'd refuse 4 or 5 times. We still don't have that rarest group, the ones that said 6 or more times, but at least we have more of the kinds of people that were in the population. But this still isn't quite right. So the 30.2% is an underestimate now of what was really true. And the 52% that indicated they'd only refused once is now an overestimate of what is really true. The 9.8% is pretty close, but the 7.8% that said they'd refused 4 or 5 times is still quite a bit bigger than was true in the population as a whole. So this is still not very accurate, even though we've got a huge sample of 100,000 people, and we picked a whole different neighborhood, and it's still quite wrong. So apparently we don't know exactly where in the population to look in order to find a representative sample of people. So in all 4 of these cases, we've used a convenience sample as a way of selecting the cases, and all 4 of them have been inaccurate. So what would happen if we used a different method for generating the sample, such as a random sample? So in the next video, we're going to show a couple of examples of what you get if you use a random sample of this population and see how accurately those samples represent what's true in the population. So we'll take a look at that in the next video.